If you would like to know about what do you mean by pipelining, subscribe for the video pipelining and you'll be able to understand about pipelining. In this lecture, we are going to learn about the different type of hazards we will come across in the pipelining technique. Okay, so what do you mean by this hazards? Okay, hazards are the issues or the problems that will arise when multiple instructions are executed parallelly. There are three different types of hazards. The first one is a structural hazard, or this can also be called as resource hazard. The second type is a data hazard, and the third one is called as a control hazard. Okay, so what do you mean by the structural hazard? Okay, so when different instructions are conflicting for the same resource at the different clock cycle, at that time, okay, so we will come across a type of hazard that is called as structural hazard. The second type, it is called as data hazard. Okay, so what do you mean by this data hazard? When one instruction requires a data from another instruction which would not have been completed. Okay, only after that instruction is completed, it will be able to forward the data to the second instruction. Okay, so this time we will come across a type of hazard called as data hazard. Okay, and the third type of hazard, it is called as control hazard. This is a hazard we will come across when do we come across a branching instruction. Okay, so such as the looping statement, a jump, call. Okay, so during that time we will come across a type of hazard called as control hazard. Okay, so now we will look at each and every type of hazard with an example. Okay, so in this diagrammatic representation, okay, so here we are clearly understand, okay, so all the 5 different stages that come across in the pipelining process. So in this example, okay, so at the clock cycle 1, okay, and the clock cycle 4, okay, so I1 instruction is referring to the memory. Okay, so in the first clock cycle, the memory is referred in order to perform a read operation. Okay, so the instruction is read from the memory, and at the clock cycle, okay, the memory is referred in order to perform a write operation. Okay, so but as the time passed by, okay, you can visualize that an I4 instruction is coming. Okay, so here we see that at the fourth clock cycle, instruction 1 is referring to the memory in order to perform a write operation. And at the same clock cycle, I4 instruction, okay, is referring to the memory in order to perform a read operation. Okay, so here we see that I1 and I4 is conflicting for the same resource memory, okay, at the different stages. Okay, so to avoid that problem, okay, so what is being introduced? A bubble is being introduced. Okay, what do you mean by this bubble? Okay, so nothing is being done during that particular clock cycle. Okay, so we see that, and then after introducing the bubble, okay, so at the fifth clock cycle, okay, so the instruction, okay, is trying to I4 instruction is trying to perform a read operation from the memory. Okay, so now you see that there is a conflict between the instruction I2 and I5. Okay, so I2 is referring to the memory at the fifth clock cycle to perform a write operation, and I4, okay, is referring to the memory in order to perform a read operation. Okay, there is a conflict. Okay, so if there is a conflict, they are trying to introduce a bubble where nothing is done during the particular clock cycle. If still the problem continues, okay, so what we can do is, okay, so we need to perform the partition, okay, of memory into 2 different partition, one to perform a read operation and the other one to perform a write operation, which will be quite complex. Okay, so this is an example how memory is referred, how there is a conflict that occurs. This is an example of structural hazard, how the register file is accessed. Okay, so in this example, the instruction 1, okay, at the second clock cycle, it is referring to the register. Okay, so where the operands are read from the register. Okay, and at the 5th clock cycle, okay, so the processor is performing a write operation into the register. Okay, so here we see that the register is used in order to perform both the read and the write operation. Okay, so if you watch the diagram closely, okay, so we see that at the 2nd clock cycle, okay, so the register is divided into two partition. Okay, so the left part is a dotted part and the right portion of the register is a solid portion. Okay, so why these two different portion? Okay, so the left part is where the instruction is decoded. Okay, and in the solid part right, it is mainly used in order to perform the read operation from the register. So now you go and refer to the 5th clock cycle. Okay, so here also the left hand side is a solid path, okay, and right hand side, okay, is a dotted portion. Okay, so why the left hand side is always used to perform a write operation, okay, and the right part of the register is mainly used to perform a read operation from the register. Okay, so now we see that, okay, so the next instruction I4, okay, at the 5th clock cycle, okay, it is performing a read operation from the register. At the 5th clock cycle, I1 is performing a write operation. So how this is resolved? Okay, so only because the register is partitioned, okay, as the register has two different partition. Okay, so one is used to perform the read operation and the other one is used to perform a write operation. By this is how, okay, so the conflict for the register resource is resolved using the structural hazard. The second type of hazard, it is called as data hazard. Okay, so what do you mean by this data hazard? Okay, so it's a type of hazard when one instruction requests a data from another instruction which have not been completed yet. Okay, such type of conflict is called as data hazard. Okay, so in this example, you can visualize that the first instruction is performing the instruction that is R1 plus R2 is equal to R3. Okay, so the register value R1 and R2 is added and the result have to be stored in the register R3. Okay, so the first instruction, it goes through the sequence of process as I have explained in the previous lecture. Okay, so at the 5th clock cycle, okay, so we could see that only by the end of the 5th clock cycle, we will be able to obtain what is the value of the register R3. But you can visualize, we see that the second instruction I2, okay, it is performing R3 plus R4. Okay, so here we see that R3 plus R4, it requires at the 3rd clock cycle. Okay, so R3 is available only at the end of the 5th clock cycle. Okay, but here R3, okay, it requires this resource during the 3rd clock cycle itself, okay, which is not have been completed by the first instruction. Okay, so this is a problem for the data hazard. Okay, so how we can resolve the data hazard? By introducing a concept called as register renaming. Okay, so rather than having the same name, okay, so since the I2 instruction was using R3 register, okay, so now we see that clearly the R3 register have been renamed, okay, to some other register file. Okay, so R6 plus R4, okay, so which does not hold any variable, maybe it would be 0. Okay, so this is how the conflict is resolved. Okay, the next one is control hazard. Okay, so control hazard, it's a hazard, okay, which occurs whenever there is a branching instruction occurs during the execution of the sequence of instruction. Okay, so this sometimes leads the unwanted instruction to be fed into the pipeline. Okay, so let us take an example. At 100th location, I1 instruction is executed. Okay, so at 101, okay, I2. Okay, so I2 is executed. Okay, so I2, it is a jump instruction. Okay, so jump means the program counter should have been incremented by the value of 250. Okay, so but unfortunately the processor will increment the program counter by 4. Okay, so the expected output should be I1, I2 and BI1. Okay, so but the actual output sequence which is given by the processor is I1, I2, I3 and then BI1. Okay, so first after executing I1 and I2, okay, so the control has to go to the branch instruction, okay, which doesn't happen in this example. You see that I1 instruction is executed, okay, and I2 instruction is executed, okay. By the end of the second clock cycle, when the I2 instruction is decoded, it is able to understand that the program counter should be incremented by 250, okay. So since, okay, so this is a problem, okay. So since it has understood that it is a branching instruction, okay, so it will introduce a stall, okay. So where, okay, so nothing is done during that particular clock cycle, okay. So here we see that I1 instruction is executed and then I2 instruction is executed and then a delay is introduced, okay. So why the delay is introduced? Since by the end of the second clock cycle it would have understood it is a branching instruction, okay. So after the execution of the I2 instruction, now the control has to move to the 250 memory location, okay. So which is a branching instruction, okay. So here we see that, okay, the control hazard can be resolved by introducing a delay slot, okay. So this is all about the control hazard. So from this video lecture we have understood that what are all the hazards that will occur during the pipeline and how do we resolve these hazards.